All right, everybody, and welcome back to part two. What we're going to do here is talk about histograms, and if we have time, we're going to talk about relative frequency histograms. So we're going to start out by just reviewing real quick our frequency table, because we need a table in order to do a histogram. So, and remember, a histogram is just frequencies over intervals, right? So it's different than a bar graph, because bar graphs are different categories, but frequency tables and histograms talk about intervals. So taking a look here, we have our classes already set up. And to figure out those classes, I knew that I wanted 5 classes, and to figure out the class width, I took the range divided by 5. I got 9, but I always need to round up, so I include all the data that's in the set. So I rounded up to 10, so that's why my class boundaries here are set up the way they are. Class boundaries are plus and minus a half. On either side, so that our histogram bars touch, because we're going to use boundaries here momentarily to set up the bounds of our histogram. Tallies, we went through the data, we tallied everything up, we found the frequency, and we're going to do relative frequency a little bit. But first, let's just start off with graphing the histogram. So if I head down here, and if I can see both my chart or my frequency table and my graph down here, what we're going to do now is actually construct the histogram. And to do this, we need to do a couple of things. We need to first list out our boundaries. Typically what we do is have a broken graph here, because we're not going to be starting at 0. We're starting at our lower bound on our frequency table. So we're going to always start out with our lower bound of 1.5 in this case. So it's going to be our lower bound of our first bar of the histogram. Now we go to the upper bound. So this is going to be 11.5. 11.5. Now, I know that my boundaries are going to touch here, so I can just skip 11.5 again. I don't need to rewrite it. I'm going to go to 21.5. So 21.5. And then I'm going to go to the next bound, which is 31.5. And then I go to 41.5. And lastly, 51.5. 51.5. Okay, so I have my boundaries set up for my bars. I'm ready to go, but what I need to do is list the frequencies over here on the left-hand side. So these are my intervals across the bottom, and then my frequencies are going to be on the left-hand side of this graph. So I have to at least go up to the maximum frequency. So my maximum frequency here is going to be 9. So let's go up to 10. So we'll go by 2s. So 2, 4, 6, 8, and 10. 2, 4, 6, 8, and 10. That should give us a general picture of what our histogram is going to look like and overall distribution shape. And as you notice down here, we actually have 1, 2, 3, 4, 5, 6 boundary marks, but I only wanted 5 classes, which is perfect because I have 5 gaps here. And that's where we're going to actually be constructing the histogram. All right, so now what we're going to do is look at the tallies, and we're just going to draw the bars across. So let me go ahead and get a box here. We're going to start out at 1.5, and this first bar is up to what? It's up to 8 in this case. So I'm going to come across to my next boundary, and I have my first bar. So next thing I have to do is, again, insert another graph. So I'm going to start out at 11.5. And now I'm constructing another bar that's right up against, because histograms are measuring intervals, so they need to butt right up against each other. So now this one I know goes to 9. 9 in this case. I'm going to go ahead and insert the next one. And as you can start to see the pattern here, you should be able to pick up fairly quickly how to construct a histogram. My next ones are just 1s, so this is going to be heavily skewed right. And I'm just going to go. All right. So that's how you draw the histogram. What we're going to do now is talk about relative frequency histogram. And the cool thing about a histogram is that you can actually see the frequencies spread out over top of all the intervals. So the more classes that you have, the clearer the distribution shape is going to be. I'm going to cover that in a later video. Is just the various distribution shapes that we have. But this one would actually be called skewed right in this case. So let me just make a note here. Skewed right. Okay, skewed right, so I can see that as my distribution shape. All right, let's talk about our relative frequencies, and we're actually going to use the same exact graph, but we're going to do something to our scale here along the right or the left-hand side, because right now it's just measuring frequencies. Relative frequencies, you got to think about this as a way to look at a histogram and compare it against multiple data values that doesn't require you to look at the exact measurements of it. So frequencies, if I have frequencies in the hundreds or thousands and I'm comparing it to something in the tens and 20s, it's going to be tough to do those comparisons. But what if I took it out of 100% and actually related these as percentages rather than frequencies as total numbers? So relative frequency, it's just percent out of 100%. So how we're calculating each one of these is we have a total of what, 20 frequencies. So I have to calculate the relative frequency by taking 8 divided by 20, 9 divided by 20, 1 divided by 20, and so on and so forth. So I take each one of these, and remember this process because we're going to use this then to measure our scales in just a little bit. Okay, so frequency, again, out of 20, so we have 8 divided by 20. Now, we all should know what 1 divided by 20 is. That's 5%, so 0.05, 0.05, 0.05. 8 would be 40%, 40, or 0.40, and then 9 would be 45%. Now, what should this all add up to? Okay, hopefully it's pretty clear. It needs to add up to 100, right? Or just 1 in this case. So this entire column, if I add it up, equals 1. Now, what happens if you add up to 101% or 99%? That just means that at some point you had to round to get it to fit in our relative frequency, and that's okay. We know that it's going to equal 100%. If it's not represented that way when you round it, it's okay. You're still going to get similar results. Just know that that's part of the error process. So our relative frequencies here, just going straight down the page, that's what we're going to use to write on our left-hand side, because we already have our histogram and it should look exactly the same, just we're going to change the scales of the left-hand side. So 2, 4, 6, 8, and 10. What we need to do is do the same thing that we did with our frequencies, because we would just want to reuse this graph. So 2 divided by 20 gives us 10%, so 0.10. Okay, and then 0.20, 0.3, 0.4 for 40%, and 0.5 for 50%. And if you look here, let's compare them. So 8 out of 20, we knew that the class from 2 to 11, or the boundaries 1.5 to 11.5, had to tally up to a frequency of 8, right? Or a relative frequency out of 100% of 40%. And if I look here, boom, 40% right there. I knew that my next class had to be 45%. Boom, 45%, halfway between 40 and 50%. And then down here, these are all 5% because they're halfway between 0 and 10%. All right, so hopefully you can see the general correlation here between relative frequency and frequency. Relative frequency allows us to view multiple different data sets, and it doesn't matter how many numbers are in each of those sets. It doesn't matter the population or the sample, because I'm looking at a relative frequency out of 100% of the data. So I can get a general comparison between these across the board. All right, and we're going to use relative frequency in the next video because we're going to talk about cumulative frequency, which is then going to, or cumulative relative frequency, and that's going to translate into our ogive, which is going to be the last part of this series. All right, so this has been Mr. Corp. Thanks for watching. Tune in next time where we talk about ogives.